Hello, everybody, and welcome to our first class on custom functions in R. There's a lot of tasks we're going to be doing over and over and over again, and so it's good to write a function that you can just call something to do a longer process. We've been using custom functions such as granges and tidyverse, and these are just these command functions we're using. We can make our own set of them too. And so we're going to apply that learning functions and how to write them and store them and source them. And we're going to apply that to importing our peaks. And in the second half of this class, then taking that function to create consensus peaks, which has all the overlaps of our peak files. So we in the last few classes, we've been doing a lot of overlaps. We're going to take a quick function detour so we can write a function that will do all those overlaps for us across all of our replicates in your custom data set. So we are now moving forward with your my ChIPseq folder here, where in classes we ran in Nextflow, we ran a custom ChIPseq here. Everybody had their own sort of design file, and in class in groups. That's where we're going to be working from today. So, okay, here is our first function. Let's just get started and create our first function. So technically, multiplication and division are function. You're mapping inputs to an output, and that's what a function does. So the way we do this in R is we actually write the term function. R recognizes that you are creating a function. We're assigning the variable as the function is called fun. So we can do fun parentheses and we'll have a function that's going to multiply two numbers. So it needs parameters. In this case, we're giving it two parameters. So function is a function with the parentheses, and we're giving it two parameters that we're defining here for this function, X and Y. And then this open bracket starts the function and says, do what is happening after this here. And so we're going to make a temporary variable of answer that is the multiplication of X and Y. So this function is just going to simply multiply any two numbers you input into it. And then we have return. So the key thing is starting it with function, telling it what parameters you want, what you want it to do in between the curly braces, and then return what you want to return. And in this case, we created an object answer inside this function, and that's what we want to return is the answer. Okay, so it sounds pretty simple, but there's a few things to watch for in here. We'll talk about local scope of a variable versus global scope that's sort of in our environment. Okay, so here we go. Let's run this code, and we close it off here with this closing bracket. And now we have a function we can run in our console, or you can run that code there, and I can type in fun 2 times -4, and I get -8 as my answer down here. So now we have just created a fun function, and what fun it is, and it's here in our environment under functions. And so the environment currently knows about this function. But what we typically want to do is store it so that when we start a session, we can source these functions that we've made and have them just appear in our environment right away, and we don't have to run them. Okay, so that's in our util, and we're going to go do that in a second. But your function, you want a little bit of documentation. So as an exercise at the bottom, you'll make an import peaks function and then go back to this same document we're going to make and add another function to it. Okay, so you want a description, and the markdown here is a pound tick mark or single quote. And so that lets you know in the markdown that this is a function, a description, we should have this here, just describing what the function does. In this case, just sorry about this is bothering me. that it's going to multiply the x and y, and then the parameters would be x and the parameter y, the two numbers you want to multiply, and then the actual function's code. And so that's what we would want right now. So we can actually take this and copy and paste it, but then we're going to practice doing this, and it's good to do it on your own just to make sure you can do it, source it, and then run it. Okay, so we're going to copy and paste this, and now we're going to change our working directory. Again, it's always important to remember where you are, and at the top directory of where you cloned the class, there's a folder called util, and I'm going to go there and set this as my working directory, because this is where I want to save this function. You usually save your functions in a util folder, and then you can source this R script that we're going to write right now, and it will, excuse me, load the functions into the environment. Okay, so I've copied and pasted this. Now I'm going to do File, New R script. So I get a blank document here. I'm just going to triple check that. Okay, and now I'm going to paste in our function description here of fun, and I'm going to save it in my util as test class functions .r, and I'm going to copy and paste it because it's going to be handy in a second. Okay, so I'm going to save that, and then now let's go back to our markdown and run this, where we're going to clean our environment. So go over in your environment window here and hit the broom there. Okay, so now it's empty, and so we don't have fun. So if we go down here, fun 2 times 6, it says error, could not find function fun. And that's because we ran it and created it in the document previously, but now that our environment's clean, it doesn't know about it anymore. So what I'm gonna do is source it here. We're gonna source this R thing, and this is really handy to do as you start collecting functions. You can just load them right in. And so I'm now, my working directory previously was classes 04 R basics. We're finishing with our last two functions classes here. And so I'm going to set this as back to my working directory now that I've saved my test class functions in the util folder. I should see test class functions and see that function fun in there. Okay, all connected, and I can see that that is 2 directories up from where my current working directory is. So I'm going to go back to it, and I can see that in R basics, I have to go up to classes and then to class 2023 to get to my util and set the path there. So I'm going to reload packages, and now I'm going to source that, and we can see function has now come back up in our environment. Awesome. So now we can do function is 8 times 7, and we get the answer 56, and we can run function for the rest of the session, and so on. Okay, so that's excellent. So you have now created your first function, and you can follow those exact same steps and the same kind of markdown, and just add it a few spaces down in that in your my class functions script, or whatever you wanted to call it, and then you can source it again and do it. It's a really good thing to learn how to do, and a good thing to have those functions so we don't have to run them every time in class. Okay, so now what we're going to do is start to make a function that's more applicable to our data, and what we're going to do is develop a way of going into a directory and loading a bunch of peak files into G ranges. Now, this is so common that you're going to have dozens of files, and you don't want to just try and upload them each as one variable. And so you can load them all at once, and we're going to make a function to do that because we're going to want to do that a lot. Okay, so in class, I'm setting my base path here. This is basically where the class is cloned. Here, so this is just so we don't rewrite over each other's files. Okay, so, and then the base path is we're going to our new ChIPseq folder, the one where you custom picked your own DNA binding proteins from the O3 Nextflow classes, the last class. If you want to go back and run that, this is a good place to pause and go generate that data. So that came from here in our Nextflow folder. We did the poll2 data as we looked for overlaps together, so we'd all have the exact same results. And then we each did a custom ChIPseq. So that's where this goes to. And then I'm going to use this file path function, which is going to then create a file path by pasting together whatever we put in here, which is base path and peak path. Sorry, got base path, but I don't have peak path. Now I can make broad peak path. Okay, great. So now I have a simple variable I can use to put in this long file path here. And we're going to make an FL object for file list. And we're going to basically go to a file path, broadpeak file path that we just created. And we're going to list the files that are in there. So what we'll see is we'll get the file path to the files. It also has handy information like the name of the protein in the file. And we're going to go and extract that as well in this function. And so we're just going to go through the function steps one by one, and then we're going to put it together into a function. Okay, so here we can set this FL to the file list, and we can see what we get back is this long file path that we had pasted together in broadpeak file path, and then all the resulting files that are in there. So like this is rest replicate 2, rest replicate 1, and some of the DNA binding proteins I had picked in there. So we're going to want to get that name out eventually too. So we're going to do that as well, because this is nice that the name of the protein is in the file name. Okay, so that's great. So we can also grep out certain, if we just want to do one protein, let's say you have a bunch of them, but you want to focus in on one, we can now look in this file list and use grep, which we went over a little bit in bash, and grep the character string EP300 in the object FL that we just created there. And so now I can see what FL EP300 is, and it's now the file paths just to the EP300 files that have that character string in them. Okay, so that's a handy little indexing. Again, the square brackets means subset out of this object something. What do you want out? I want anything with this in it and in the object FL. So we're indexing in and grabbing things out of the same data frame. Not the best explanation, probably just a better way to say is you're intersecting out data from within a bigger data frame and telling a function what to do in here, function being grep. Okay, so now we need to get the names of the DNA binding proteins. And I hope you can see what we're going here for is an RTrack layer import loop, which is going to then go through each one of these file paths and load them in as a G ranges. Just a little more indexing here. We can do FL of 7. We can see the 7th index is H3K27 methyl, histone modification, chip data. And so now we're going to use some regex. I have some website here that you can use and interpret this. We're only going to use it once, so I don't want to go through a whole anything about regex. It's something that you find something that works and you leave it alone for a while. And so what we're doing here is we're just going to do this for the one entry FL entry 7 that we printed out here, which is this H3K27 broadpeak. And so we're going to go into that index and use the function string extract, which is just basically going to grab out whatever it finds inside of its parentheses or whatever function you run. And so we're saying index FL7, and then this is regular expression, which is going to take anything with a / here. So it's going to break it up by these forward slashes, and it's going to take the last, what's after the last / So let's run that and see what Y looks like. Okay, and so we can see, yep, it's the last. We separated by all these forward slashes. It's kind of busy for that, but bear with me. And then we got back the name of the file. So now we could do another sort of separation by this underscore and take the first object, which would be the name of the protein in the file. And so that's what this is going to do here is string split is going to say, what do you want to split on? And what object do you want to split? What do you want to split on? In this case, we're going to do underscore. And so when it splits here, we're going to get position 1, 2, and 3 because there's 2 underscores. So we're going to get the first to the left is 1, the middle is 2, and the right is 3. And so that's what this 1 is doing here, is saying I want the first object after you've split them. Give me the first one back. And unlist is just taking that information back out from the string split. So this is going to be handy, and we're going to use it quite often, that you can go in to something and see that you just want a little bit of the information, and you can sort of string split it by something or gsub and replace it with something else. Okay, so let's do this here where we make that split and return just the first value. And what we see is indeed we get back just that value. Okay, so we can put these two together now and take a given one for this FL. Let's take position 28 and run it here. And oh, what happened? So we got an error. I did this on purpose, so we wanted to get this error. So this is where local scope versus global scope becomes important. Here we're defining y, but y doesn't exist yet when it's called in this function. And so this is an important thing when you're creating a function, is that you wanted above to have set y to something like we did here. So when we put the function together, you'll see that we're going to establish y before the string split function, because it doesn't know what y is at this point. Okay, so that's because it's a local variable and not global inside of this function, not in our environment. Okay, so here what we're doing, this is exactly what I was mentioning, is that we're going to actually establish y in there before we actually call on y. But we're going to do this as a function of y. So this is a bit tricky, but I think you'll catch on to it after a while. That, okay, so here what we're doing is a new function, sapply, which is sort of like a for loop in itself. It's going to take and say, I will do any given function, give me the data frame you want, and I will run any function you want on that data frame, and I will do it across the entire thing. So there's sapply for string apply and lapply for list apply. They're not totally interchangeable, but they're basically the same thing. And they are like an instant for loop. So give me the data frame, and for everything in that data frame, I will do this function that you declare. And so we're going to go through each of the lines of our file paths in FL and run function y. So we're setting the variable y, and we're then now establishing y as the first thing we do. And so we're going to say string extract, and these could be different names. It doesn't have to be y or x. And we'll see that later. But string extract here is going to be on y, which is being established as by unlisting this data frame here. So we're going to get y from the string extract of the information of each line in FL. So each line is going to be read, that split's going to happen, and then y is going to be established as that this thing here with 3 with the underscore still, and then that will be unlisted and string splitted here. Okay, so let's run that. It's basically the same code as above, but now it runs. And we can look at DBP name here, is I have 27 files, and it gives me the name of that. So that's really handy now. So when we go to upload these peak files, we can add this little bit of code we just made here. It's not very much, but it's pretty powerful, where we could say, now go to that file, import the peaks, and name it by the DNA binding protein that the file name had. And that's kind of what we just did here. Okay, so let's make this into a function to import our peaks, to wrap it all up. And then the exercise will be for you to take this code and follow the sort of thing we did for function fun, and upload this function into your R script in your utility folder. Okay, so we're going to do the same thing. We're going to call this function import peaks instead of fun. We're going to set up function for R to know we have a function, and we're going to give it a flexible parameter where you can say consensus file path. In our case, we're going to go to peak path where all of our data is, our chip data is from our custom runs. If we've been following along the same thing, that same file path should work for you. And that's why we split the base path to your folder. And then everything should be in the same order that way. And if it's not, you might want to reclone it and make it life a little easier before we start getting a bunch of results. Okay, so we're going to say the parameter I need is a file path. So my job as this function ultimately is going to be to go to a folder and grab all the broadpeak files, upload them as granges like we've been doing, and then that's it, and get the name of the DBP. And so we can import a bunch of files all with one function. Okay, so there is where my files are, is in peak path, which we have here. You can take a look at it and make triple sure. Okay, so yep, I'm going to my ChIPseq is where I made my custom ChIPseq, and what I called it, you might want to change that to whatever you have there. Okay, so peak files this is the list files function we just did up above, where we're going to list the files in the file path. So we're going to basically go to the file path, and then list files will make an object of all the file path names. And we're going to select just for broadpeak. Again, same code as above. And this is also the same code as that we just walked through. So then now that we have an object peak files, the next thing we're going to do is get the DBP name that we just went through this string extract on list. But let's just go through it briefly again, where we're going to use an sapply to go over all the peak files. So the peak files is where all my broadpeak files are, all 27 of them. And it's going to go for each file in peak file, each line, so 27, and it's going to run function X that we're going to establish behind this curly bracket. So X is now going to be passed over here, and we're still going to make Y the same way we did before, but we're going to run it on X because that's the variable of our function, and extract out the forward slashes and then substitute Y, which is now just that 3, this thing here, and then unlist string split and take just the left variable. The unlist here is kind of a formality. Really, the thing to focus on. String split is saying, what do you want me to look at and what do you want me to split on? What is the splitter? Sort of like when you do text to data to columns, text to columns in Excel. Okay, so let's now run this function. So everything's in there. We're good. We have a file path. And so let's try it. Nothing happens. That's just because we just made the function in our environment. We didn't actually run the function. So that's where the local versus global scope is all of these variables we were just talking about are just within this function, and they don't really exist in the environment yet. But now the function exists in our environment, and we can run it and do it here where I'm going to do a test. Okay, that worked. Oh, list of 0. Apparently I needed to do that with my broadpeak file path. I just had to troubleshoot that, but it's all set now. So what we have done is established a import peaks first part of the function that's going to give us the file paths to the peaks and the name of the DBP for that peak, DNA binding protein. So that is this code here. And now what we want to do is continue on with the function. And note that we're running a function inside of a function here. And so we want to keep going, and we haven't closed off this bracket yet. This bracket just closes off this part of that generic function X that we called. And now what we want to do is we've created the DNA binding names and pasted them out. And so now we want to import the files. So we have 27 lines of information of file paths and the .broadPeak selection. We want to run our track layer import. That's here. And so we're going to do a for loop to do that for each of the files in there, do the import function. And so what we have here is, we'll run this all in a second, but what we're doing is starting a new thing, how we sort of started Y is empty, and we're starting a new list to concatenate. And so what we're going to do is make our track layer import is going to eventually give us G ranges. And that G ranges is now going to go up into this peak list up here object. So we're setting a new object, peak list, and it's going to become a list of G ranges after every time this for loop runs through the peak file list and imports a peak file. Okay, so this is our for loop here. So for I in 1 through length peak files, which we just made up here, and it gives us the file path to all of our peak files in our ChIPseq folder. We're going to go through each line, so 27 in my case. And peaks is now going to be another thing that we're going to load in this function with our track layer import is peak file I. So for the first line in peak files, give me the file I, or the first one. And then what it's going to do is combine peak list with peaks. So this is just made for our first entry so far, and we're going to merge it into our peak list here. And so what we got out of peaks is a G ranges of a given peak file. So you can think of this as just our track layer import as we have been doing, and get our peak file for the entry I, and then concatenate that into peak list object, sort of put the peaks in there. And then we're using this names function that the names in the peak list is the DBP name of I, which we've created with this code up here. And it's got the DBP name as the output of our first part here. And we're going to take the, for each of the times it's doing this, it's going to put the name of the DNA binding protein on the peak list. And we'll see that in a second. And then have it return peak list, which is the last object it's making. And this will add the name here. If we didn't add this, if we take this out and run it, we'll see something different. So let's go to the top here. And we've just added a for loop simply to the code we just went over to import each of the files and make keep returning that G ranges to one object. So previously we loaded in files as one object. Now we're going to have a list of those G ranges of peaks. Okay, so let's go to the top and run it and just go through it. I'll do it. Nothing happens. That's because we just established the function here. And so now if you want to actually do this, you can do now run import peaks, which you have as a function in your environment, and it needs the consensus file path here is the variable it needs. So we're going to say consensus file path equals broadpeak file path that we created up above. I've repasted it here for your convenience, and then run that. And it's going to take a second because we're actually loading in each of those ChIPseq files as an object, and I should have 27 in mine at the end, and we'll take a look at what this looks like. Okay, finished, 27 elements, that's great. And so I can see each of these is a genomic ranges for a given peak file, but because I took that name part off, Now I wouldn't know which is which until I looked in here, and that's no fun, as we know, not a best way to look at it. So what we want to do is just unpound that last bit there, where we're using the names function to name the rows of the list of G ranges by the DVP name here. Okay, so that is our peak list functions essentially here. You can clean it up and move it to your util, but now you have a function here for import peaks, which will give you all your peaks. Oops, I'm going to rerun that so we get the name back. So let's just rerun like we just did here, but we now have that names, and then run the command. Import peaks takes a second here, and I'll have my peaks, and then you can put this in your functions folder, and now you can clean your environment and test run here and make sure that you can do that. And just as a fun last little thing here, we've already, this is just to rerun it after you've cleaned your environment, all this up here. We can do an sapply here over my peaks now. So now we're back in genomic ranges land, and we can start to do find overlaps and other things. And this one object has all of our peak files. So we can grab out certain ones and compare certain ones to others, and do it more flexibly rather than having 27 different objects in your environment. And so we can do sapply, which we sort of started learning above, across my peaks, which is going to be a G ranges object that's now named because of that names attribute in the function. And we're going to convert it to a data frame. So we can go simply run this num peaks, and what we get back is in our environment number of peaks. So we can see already how many peaks are in each file, which would be important information, but we did it for all 27 at once rather than having to do them iteratively. So now looks like I didn't finish the exercise, but the exercise is to create a function in your class functions.r file, and then clean your environment and reload it. So congratulations, you've made some functions, and now we're gonna, in the second half, do the overlaps just the way we sort of imported the peaks, and we can now run functions across all 27 and get information. And then now we can do overlaps across all of them as well. So that's the next half of this class on how to make an overlap for loop and create consensus peaks. And we will be all set to start moving forward with our bigger and custom data analysis. So thank you, and be well.